So here's another nice question. So this is the limit as n tends to infinity of 3 upon 1 plus n cubed plus 12 upon 8 plus n cubed and so on. So the general format for this thing is 3r squared upon r cubed plus n cubed. Now if you try using algebraic methods, you will just not be able to find anything from this. So here's what I did. So I consider this thing natural log of 1 plus, wait, not exactly 1 over there, it was right, so it's gonna be r cubed, sorry, r plus 1 cubed, yeah, so it's gonna be r plus 1 cubed upon n cubed plus 1 minus natural log of r cubed upon n cubed plus 1. Okay, so this thing is going to be, if, okay, so let's write it like this: natural log of r plus 1 cubed plus n cubed upon r cubed plus n cubed. So this is just tending to 1 and it's slightly bigger than 1, so it's going to be natural log 1 plus this thing minus that thing, so that should be 3r squared plus 3r plus 1, okay, upon r cubed plus n cubed. Good. So this thing is going to be, so using the Taylor series expansion of this function, natural log of 1 plus x, right? So there's a Taylor series expansion for this function, which can also be derived simply using this GP formula, 1 upon 1 plus x, that thing is 1 minus x plus x squared and so on. So if we just integrate this, right, so that's gonna give us natural log of 1 plus x equal to x plus okay, x minus x squared by 2 plus x cubed by 3, so on, right? And we're gonna integrate this from, say, some values. We put 0 to 0 to x, right? So this is also going from 0 to x, so when you put 0 and x over here, you just get this equation, right? So that's basically the expansion for natural log of 1 plus x, and I'm going to use that. So this is going to be 3r squared plus 3r plus 1, and notice that this thing is approaching 0, right? Yes. R plus 1 upon r cubed plus n cubed, cool, plus some other stuff which has its squares over there. It's like this thing, r cubed plus n cubed square, so on, right? So this thing can be written as 3r squared upon r cubed plus n cubed plus so it's gonna be 3r plus 1 upon r cubed plus n cubed plus 3r, I mean all that stuff, so that thing squared and so on, right? So the big important thing to notice is that if I multiply this, okay, so let's just write the final term. So the final term is going to be 3n squared upon n cubed plus n cubed plus 3n plus 1 upon n cubed plus n cubed, and the final term is also the largest term, which is also like a finite quantity, so that's going to be 1 plus n cubed plus 1, right? So some square stuff over there, which actually, right, so that has the power, so it's n squared over there and n cubed over there, so it should be like 1 upon n, and that thing squared is like 1 upon n squared times other constant stuff, whatever. Yeah, so if I multiply this thing by n, so what I'm doing essentially is that I'm finding an upper limit to this sum. So if all of these terms were as big as the last term, then this would be like 3n cubed upon 2n cubed, right? So this thing cancels, plus, but over here you just get 3n squared upon something which is like 2n cubed, and then over here also you get 1 upon n times some other constant stuff, right? So that basically means that all of this thing, that's gonna approach 0. So the largest is, this can go is like 3 by 2, and that's good, but the more important thing is that for every term, if I actually take the largest limit, that in the largest value that this thing can go to, that's actually 0. So what that means is that this is in fact negligible, right? So even if you sum all of these values up from r equals to 1 to n, it's still going to be negligible. It's, yeah, so it doesn't even count. So we can just erase this, right? So that that doesn't even count, in fact. So right, so if I just sum these things up from r equals to 1 to n, these things, right, so these things like won't count, because the largest their sum can go is 0, right? So that's nice, which means we just have to sum these things up from r equals to 1 to n. Right, and that's exactly what this is. So what that means is that summing these things up, right, summing this function from r equals to 1 to n is the same thing as summing this function, where was it, this thing, from 1 to n, because all of that is 0. Good. So we can just replace this by that. So it's going to be the sum from r equals to 1 to n. What is this thing? Natural log of, what is this, r plus 1 cubed upon n cubed. Actually we should be, yeah, let's just do this, r plus 1 cubed upon n cubed plus 1 minus natural log of r cubed upon n cubed plus 1. And guess what, this is a telescoping series, so if you put 1 over there, it should be natural log of 2 upon n cubed plus 1 minus natural log of so it's just going to be 1 upon n cubed plus 1, right? And then plus natural log of 3 upon n cubed plus 1 minus natural log of 2 upon n cubed plus 1, and so on. So till when? Till n. So it's going to be natural log of n plus 1 upon n cubed plus 1 minus natural log of n by n cubed plus 1. Notice that all of this cancels, so this cancels, that cancels, and so on. So this is also going to get cancelled, right? Good. So it's just going to be natural log of, well, what's this thing approaching? It's approaching 1. So it's going to be 1 cube plus 1, which is 2, minus, what is this thing approaching? It's approaching 0, so it's going to be natural log of 1. Well, this thing is just 0, so natural log 2, that should be the answer. So that's one way of doing it, and the other, the more easier, I mean, yeah, it's slightly easier. So the other thing which you can do is notice that in fact this thing is very similar to an integral, right? So what I mean by that is you have this function 3r square upon r cubed plus n cubed, right? So this thing can be written as, so if I just say that yeah, so let's say that r by n equals to x, yeah, that might work, might not work, let's just say that. So r upon n is x, so this is going to become 3n squared x squared upon x cubed n cubed plus n cubed, which is 3x squared upon x cubed plus 1, and then you got 1 upon n, right? And we have to sum this up from r equals to 1 to n, and this thing is like 3x squared upon x cubed plus 1. And notice that this thing is actually the increment in the value of x. So initially, suppose you had r upon n, then after an increment it's going to become r plus 1 upon n. So the increment is in fact of 1 upon n, and that increment is very small. So this is comparable to dx, right? And now we can just turn this sum into an integral. So it's an integral from, well, r equals to 1, that's going to give us x approaches 0, so like 0 to, when this is n, x is 1, so 0 to 1 of 3x squared upon x cubed plus 1 dx. So this is going to be, yeah, so you can do this thing, 3x squared is just the derivative of this denominator stuff, so it's going to be natural log of x cubed plus 1, and this is going to go from 0 to 1. So this is going to be natural log of 2 minus natural log of 1, which is exactly what we got at the end, right? So this is just 0, so natural log 2 is the answer. So that's it. I will see you in the next video. Peace.